Good morning and good afternoon, everyone, depending on where you're joining us from. Thank you for joining today's webinar, Understanding the second edition of the API RP 1170 and 1171 and their impact on the underground natural gas storage operators. My name is Shreyas Rajshekara. I'll be your moderator today on behalf of RCP, the Pipeline Safety Institute, and TASCOP. For those who may not be familiar with us, RCP is an engineering consulting firm based in Houston with more than 30 years of experience serving the pipeline industry. The Pipeline Safety Institute is the RCP's training division, providing pipeline safety and regulatory trainings, while TASCOP is our cloud-based workflow and asset management platform. RCP has extensive experience supporting the underground natural gas storage industry. Our storage clients represent 60% of the working gas storage capacity in the country. Our services include well and reservoir risk model development, storage integrity management program development, and continuous process improvements, regulatory audit preparation, storage risk management. We also offer storage risk management V2, which is hosted on TASCOP platform. Before we begin, just a few housekeeping items. Today's webinar is being recorded and will be shared with all the registered attendees. Request everyone to be on mute. You'll get an opportunity to ask questions at the end of the presentation, or you also can post your questions in the Q&A feature, which is available in the Teams at the top, and we'll try to address that at the end of the presentation. Now it's time to introduce our speakers. Our first speaker, Phil Baker. Phil has more than 4 decades of experience in the natural gas industry and has numerous technical and leadership positions related to underground natural gas storage and pipeline integrity. He has been deeply involved in industry standard development and brings extensive expertise in regulatory compliance, risk management, and storage integrity programs. Phil, thank you for joining us. Also, I'm pleased to welcome our second speaker, Mr. Stephen Nowachevsky. Steve is a recognized subject matter expert in the underground natural gas storage, integrity, and risk management, with extensive experience supporting operators in program development, implementation, regulatory compliance. He has been actively involved in advancing industry best practices and helping organizations navigate complex integrity management challenges. Steve, thank you for joining us today. I now turn it over to you both. Thank you.
Thank you, Shreyas, for introducing Stephen and I as part of the RCP Underground Storage team, and to all of you here online taking time out of your busy schedule to listen and participate in this webinar. It's a pleasure for us to be presenting to this audience. We hope you find the PHMSA compliance-driven information we will share today enlightening and useful for your ongoing storage operations. Our time this afternoon will focus on 2 second edition API publications. API Recommended Practice 1170, Design and Operation of Solution Mined Salt Caverns Used for Natural Gas Storage, and API Recommended Practice 1171, Functional Integrity of Natural Gas Storage in Depleted Hydrocarbon Reservoirs and Aquifer Reservoirs. Throughout the presentation, you may hear us refer to these documents as simply 1170 and 1171. So as to a simple introduction to the agenda today, I will begin by briefly touching on some background of the historical PHMSA underground storage regulations that operators must comply with. Then we will discuss some common themes that exist among the updated compliance-driven API recommended practices. This will be followed by more details on the changes and effects for both 1170 and 1171 you can expect to significantly impact storage operations. We will then address several frequently asked questions compiled from among the many gas storage clients that RCP routinely interacts with. Lastly, near the end of the session, we will open the webinar to address any lingering questions that participants may have on what was presented. So as for a brief general background, you may recall that in January 2017, PHMSA's interim final rule incorporated 1170 and 1171 into 49 CFR Part 192 of its federal pipeline regulations that mandated adoption of functional integrity, safe operation, and risk management disciplines for underground gas storage in depleted hydrocarbon reservoirs, aquifers, and salt caverns. Thereafter, in March of 2020, the final rule that used the first editions of API 1170 and 1171 as key components supporting functional safety of natural gas storage systems became effective. Last July, PHMSA issued a new ruling effective January 1st, 2026 that formally incorporated the second editions of 1170 and 1171. However, last summer's rulemaking declaration was followed in early December by a notice of limited enforcement discretion, which in general deferred API Edition 1 to Edition 2 enforcement actions until after January 1st of 2027. So to recap, the PHMSA enforcement discretion period we are now within will allow storage operators additional time to better support an orderly migration of impacts resulting from the second editions of API 1170 and 1171. This could include implementing updates to integrity management plans, procedures, and processes, adjustments to risk modeling efforts, and conducting any necessary personnel training. However, it should be noted and emphasized that PHMSA, even with their notice of limited enforcement discretion, still retains the authority to take enforcement actions if significant safety or operational concerns arise. Steve will now discuss the drivers behind PHMSA's adoption of the updated revisions to 1170 and 1171. He will then introduce some common themes that exist among the mandated recommended practices, followed by some details adopted within 1170 for salt caverns. Steve, please take it from here.
Thank you, Phil, and good day all. So what drove the revisions? The second editions of 1170 and 1171 were published in late 2022. They result from the storage industry API task group diligence to update the standards on the recommended approximate 5-year basis, according to API. These later versions represent advances in standardization, where practical, of common integrity management elements for cavern and reservoir facilities, and lessons learned from experience and maturity building through operations and audits, and lessons learned from other issues and incidents, as well as overall experience and direction of the oil and gas industry at large in safety and integrity management. Next slide. When we realize that the second editions come closer to each other in terms of standardization, what we can find are there are at least these 6 common themes. They include aspects that you see here on the slide. So the engineering and geological design, investigation, planning and review, well design, construction, maintenance, again, life cycle activities, risk management, and life cycle integrity inspection, monitoring and testing, site safety and security, and procedures and training. And then each standard, of course, has features unique to itself. So like 1170's got the sections on cavern solution mining, conversion to gas storage, and cavern workovers. The second edition of 1170 includes new sections 8, 12, and 13, which are very close copies of sections 8, 10, and 11 of 1171. So we can see that these new sections standardize requirements for risk management, site safety and security, and procedures and training across all underground natural gas storage facilities. The second edition of 1170 contains 121 more shall and should statements than the first edition, 65 more shalls and 56 more shoulds. Most of the sections have minor increases in the shalls, mainly at the expense of shoulds, where statements got converted to a shall statement in things like sections 5, 6, 7, 9, and 10. And gas storage operations in section 10 had some more restructuring, with many of the shoulds moving to and being replaced by requirements in the second edition, sections 12 and 13. So most of the new requirements in 1170 for caverns relate heavily to sections 8, 12, and 13, which together in total have 46 shells and 94 shoulds. Cavern operators will need to update their existing procedures or create new procedures and edit their SIMP plan in order to cover the 1170 second edition requirements. It's also helpful when you're doing that to notice and review and apply as applicable the additional normative and bibliographic references that are found in the second edition, and also align your definitions to those in the second edition of 1170. Cavern operators have been required to apply the essence of 1171's Section 8 on risk management, but now the second edition of 1170 specifically aligns to cavern operations, and the shall and should statements have been upgraded. There are several significant items. First, you should verify that your risk assessment models incorporate the threats as listed in Section 8, Table 1, as well as looking at potential threat interactions amongst those threats. Second, should verify that you are reviewing and determining applicable preventive and mitigative measures from Section 8, Table 2, as well as Section 11, Table 3, or Annex B. And third, operators should verify that they review their risk management activities annually, including how their risk models have characterized and ranked risk, evaluate the effectiveness of your P&M measures, and develop and track storage integrity management program risk-informed performance metrics, ideally with leading and lagging indicators and application of a LARP, or as low as reasonably practicable, to risk-informed decisions. Cavern operators have been required to apply the aspects of site security and safety through various equipment and facility requirements that had been in the first edition, Section 10 of 1170, but now Section 12 of the second edition aligns to the same requirements as in 1171, Section 10, and the strength of the recommendations has been upgraded via more shall statements. Operators will need to verify that their storage and well emergency plans and well control plans align to the new requirements, including training. Further, operators might need to add or modify procedures and work practices to perform well site safety and security reviews or other ongoing monitoring of well site conditions to identify threats, assess the adequacy of safety and security measures, identify changes in threats, and modify or add prevention and mitigation measures accordingly. Cavern operators are required to have a full set of procedures to cover life cycle cavern and well activities. The process of continual improvement and regular periodic review and adequacy assessment of the procedures must be built into the operator's SIMP, along with management of change for life cycle activities, which includes procedural and administrative activities and document management, as well as technical changes. Additionally, operators should have training and competency assurance processes governing those persons, including employees, contractors, and supervisors who are engaged in any SIMP lifecycle activities. I'll turn it over to Phil now to talk about some specific changes in 1171.
Thanks, Steve. There's a lot of numbers on this page, but the bottom line is that the second edition of 1171 contains 20 more overall should statements than the first edition. Most of the changes from the conversion of selected shoulds to shalls in sections 5, 6, 7, and 9, along with some new requirements within sections 8 and 10. Section 11 was streamlined somewhat to reduce and eliminate numerous should statements. The next several slides we will review in more detail some of the more significant changes now in sections 6 through 11. With the number of new 1171 should shall changes that were just presented, here's a short list of high-level to-dos that storage operators will need to implement for compliance. First, you must sufficiently address all of the converted or new shall statements within your related documents and procedures. Any new definitions or references should also be incorporated within your integrity management plans. Any risk assessment models that include interactive threats should be updated to incorporate the newly added threats as identified in Section 8, Table 1. Preventative and mitigative measures that exist will now need to be addressed for their effectiveness. And lastly, performance measures and metrics with leading and lagging indicators will need to be developed and tracked. So now let's dive into some of the details as to what has changed specifically within the risk management section, Section 8. There's a new subsection on risk management that discusses annual reviews, roles and responsibilities, third parties, and risk assessment process requirements. The concept of ALARP, as Stephen mentioned earlier, was also introduced here. Clauses on the identification, validation, and retention of data sources were also added. Threat and hazard identification and analysis was strengthened with some shall statements. And periodic review and reassessments now require a review of performance evaluation adequacy, P&M measure effectiveness, and performance measures. Continuing on with the expanded details within the risk management section, here are some additions to the threats identified within Section 8, Table 1 that now need to be assessed. The lack of records or information, the use of incorrect information, subsurface encroachment, pressure volume limits, geo uncertainties, and surface threats and flammables existing on site. Furthermore, Table 2 in this section added some mitigations for the threat additions made in Table 1. Moving on to some detailed changes within Section 10, Site Security and Safety, new should statements were added for site security procedures, access and access control, and communications. There's a new subsection with shall statements for an emergency assembly area and another for safe work practices. Should shall statement additions or changes were made to site inspections, emergency preparedness, and emergency response plans. The well control plan topic had a new shall statement added on managing uncontrolled releases of gas. And lastly, in Section 11, a should statement was changed to a shall for training operations and maintenance personnel. Reservoir integrity monitoring is addressed in sections 7 and 9. The monitoring of commissioning risks and inventory assessments are now shall statements. In section 9, a should statement on updated engineering characterizations as data becomes available has been added. Inventory assessments are now shall statements for material balance studies, measured and unmeasured inventory changes, and calibration of pressure gauges. Lastly, flow monitoring is now a shall statement with should statements for integrity evaluation related to flow monitoring. Well integrity is addressed in sections 6 and 9. Section 6 had several new additions, including emergency shutdown valve evaluations for new facilities. New tubulars must now meet API 5CT specifications. New shall and should clauses on production tubing now exist. 2 should clauses for connections, along with a reference to Annex A with its various types of connections commonly used for tubulars, a new section 6.5 on well barriers, and lastly, the evaluation and responsive action topic was added with 2 should statements. Section 6.10.3 is new with shall statements on a conversion of wells to gas storage service. Further sections introduced well schematics with the inclusion of 4 should statements. Lastly, Section 9 added shall statement that requires the investigation of metal loss and its impact on operating pressures for tubulars. We realize that a lot of detailed information has been presented thus far, but we will now step back a bit and move into the next part of the agenda where Stephen will address some of the frequently asked questions we have heard from within the industry. Steve?
Thanks again, Phil. Well, frequently asked questions. We've only touched the surface here, and we thought there are some interesting things that we can talk about. We'll have time for Q&A again at the end of this, and if you need more detail, of course, you can get with us later for extended discussions. So, one of the first questions we can ask is about this whole performance management thing, and let's talk about leading and lagging indicators. So, what are some examples? In Clause 8.6 of 1170 and 1171, periodic review and reassessment, that statement requires us as an industry to move towards performance-based monitoring and measurement of the integrity management program. It requires by shall statements, performance evaluation, adequacy assessments, measures of P&M effectiveness. And so the question is, oftentimes, if you're not familiar with leading and lagging indicators, here's some examples. But remember that a may statement, it's a may statement, but we would highly advise that you start to move this way in terms of thinking about your performance metrics as leading or lagging. Leading indicators relate to actions taken to achieve your SIMP goals. That's kind of a global statement, but they could entail things such as some of the things that you see here. So developing and tracking goals and objectives and applying lessons learned. Evaluating the adequacy of information, documentation, or the closure or reduction of knowledge gaps, and the ability to use information in risk-informed decision-making. Evaluating the adequacy and effectiveness of SIMP supportive processes, procedures, tools, data collection, and management systems. Evaluating the competency training and skills development of your staff and contractors. Setting operating limits and thresholds, such as pressure ratings, safety factors, maximum allowable annual surface pressures, flow or velocity limits, sealing capability or leak rates of valves and relief devices. Could also include things like the identification and reduction of nonconformance in design criteria, compromised integrity, procedures, or operational practices. Leading indicators could also be self-assessments or internal or external audits of your SIMP, and also risk assessments completed and the status of the decision actions that you've implemented. Lagging indicators often are a little bit easier to understand. They're usually describe what has already happened, and these are things that we can frequently count and trend, such as operating limit or threshold exceedances, emergent issues resulting from escalation related to findings from maintenance, inspections, and tests. PHMSA reportable events such as incidents or safety-related conditions, abnormal conditions, management of change occurrences, and any actions responsive to those findings that have been completed or not completed. And in a similar vein, incident and issue investigations and their status. While we're doing leading and lagging indicators, it's good to categorize lagging indicators in particular by barrier element or operating condition, and then by actual or potential severity of the occurrence. So, for example, barrier and operating conditions could include your observations around annulus conditions, flow or fluid or pressure conditions, well site conditions, wellhead valve and ESD condition and functionality, the condition of your downhole equipment like your casings, tubings, cement. On a reservoir or cavern scale, your gas inventory and pressure volume relationships, your boundary and third-party issues, or other integrity monitoring activities such as cavern creep or subsidence, as well as storage injection withdrawal reliability performance anomalies. And again, to kind of focus on safety and environmental criticality categorization, that will help you in determining, the performance measures around why are we doing good integrity management. And generally, folks will break these down into about 4 categories, like major critical safety or environmental consequences, moderate to serious, minor, or at a very early level, degradation of barrier elements or adverse operational indications or operating discipline that did not lead to an event but could lead to an event. Phil, we're going to turn it back over to you to talk about a few other FAQs.
Thanks again, Steve. So what types of documents and processes will cavern operators need to update as part of 1170 edition 2? First, let's address the documentation issue. Any internal documents involving risk management, site security and safety, procedures, and training will likely need to be modified. New procedures may also be necessary under some situations. With regards to processes, operators will likely need to review any new references and incorporate associated definitions, and then revise their integrity management plans accordingly. Any risk models used will need to consider the threats and threat interactions associated with Table 1 in Section 8. P&M measure effectiveness will also need to be assessed. And finally, relevant performance measures and metrics, as Stephen just touched on, will also need to be established. As was presented earlier, Edition 2 of API 1171 added a net of 20 additional shall and should statements, but 31 more shall statements actually exist due to the conversion of some shoulds to shalls as part of the evolution from E1 to E2. So any documents involving these reference changes will also need to be updated. Some examples of these include gas inventory analysis that is now a mandatory shall, the new threats in Table 1 of Section 8. The should statement now exists for well barrier element identification and well schematics. And the safety principle of ALARP, as Stephen mentioned earlier, was introduced with the should statement. So in summary, as was the case with salt caverns, depleted hydrocarbon reservoir and aquifer operators will need to modify their integrity management plans, procedures, and risk assessment processes. And lastly, performance measures, ideally with both leading and lagging indicators to track and manage risks effectively, will need to be established. Steve, do you want to take the few remaining questions from here?
Sure, thanks, Phil. So, do the second editions mandate a deeper analysis of interactive threats than was required in the first edition? Well, the answer to that is no. The language was always there, and it really hasn't changed in the editions. The threats that are identified in Tables 1 must be reviewed at a minimum for presence and susceptibility in the particular reservoir or cavern or well system being assessed, and therefore then the potential for threat interactions also analyzed. Threat interaction analysis in clause 8.4.2 can be understood as a should statement nested under and related to the 8.3.2 shall statement. 8.3.2 includes a shall for the evaluation of both susceptibility to individual threats and assessment of threat interaction. 8.4.2 says that risk assessment should address individual threats and threat interactions. We interpret that the 8.3.2 shall requires evaluation of which threats and threat interactions are applicable to your particular system, and thus the intent of the following clause in 8.4.2 is essentially a shall. Since you're required to identify which threats and threat interactions are applicable, then you ought to assess the level of threat and potential threat interaction per 8.4.2. Also note it's good to call out that amongst the language throughout the documents, as an example, in 1171, clause 5.3.2 calls out a specific type of reservoir threat interaction, and that is gas storage pressure volume with rock fluid geocharacterization. Some examples of interactive threats, there's dozens that you could come up with. We advise clients generally that in evaluating potential threat interactions, you should write a logic statement describing how the threats interact and does it make sense and what that interaction could cause or lead to. The logic statement helps operators determine which interactions could be viable and which might be of interest in evaluating. So, for example, in RCP's version 2 risk models for caverns and wells, we offer quite a few potential interactions. We don't advise that folks do all of them, but to select which make the most sense in their particular um, facilities. So we've got a number listed here, but I'll just go over a couple. So for example, the casing corrosion condition threat when paired with potential mechanical damage during a workover could lead to an advanced failure likelihood for the casing. Or in another vein, the well intervention threat paired with a human or O&M factors threat would address uncertain process safety management of human and organizational factors during well intervention when combined with uncertain hazards downhole could lead to either a loss of control or unintentional adverse well integrity impacts in terms of damage to a well barrier element. Again, we've chosen some possible FAQs, and one goes around plug well risk assessment. What requirements are explicit and implied regarding plug well risk assessment? So we refer you to a number of clauses in API 1171, 532, 742, and 932. Plug wells can be seen as both a well integrity issue from the perspective of the well itself, as well as a reservoir integrity issue, or at large, a cavern integrity issue, perhaps, since plugged wells are a possible human induced pathway around the reservoir containment barriers. 1171 9.3.1 identifies the scope of plug well reviews. You need to identify the wells and identify the plug wells that penetrate the storage reservoir within the buffer zone or area of review using third party or public records. And then Section 8, Table 1 identifies plug wells as a specific design threat. There could be containment failure to inadequately completed or sealed plugged wells. And then, in general, a lot of the well integrity factors or threats would apply to plugged wells also, such as the pressure rating of components, lack of records, and so on. Also note that Section 8, Table 2, P&M measures point back to these clauses 5.3, 7.4, 9.3, and 6.8 that address plugged wells. Tables 1 and 2 of Section 8 compel operators to evaluate plug well integrity using records reviews covering the whole life cycle. And then also, what's important is evaluating the conditions under which those wells were plugged to today's storage operating pressure and volume and fluids. The well integrity or plug well integrity assessment should include review of the gross environmental threats to other porous zones, other subsurface uses such as injection, production, mining, and to freshwater sources. Plug well integrity should be risk assessed against the Section 6.8 requirements, which are 1171's best practices for plugging wells and storage fields. And those should be at a minimum, and you'd have to also then include any particular state jurisdictional requirements as well as your own plugging and abandonment standards. In general, Section 8 requires assessment of all applicable threats, and then, therefore, the only condition in which plug wells do not need to be risk assessed is the condition where no plug wells exist in your particular reservoir, buffer zone, or area of review. Last slide, and this will be the last one before we go to our Q&A. How can we apply a LARP? Well, it's currently a should statement. There's a lot to talk about with a LARP. We'll just cover a few high points. A little historical background, the historical usage of a LARP concepts. Again, a LARP stands for as low as reasonably practicable. They relate specifically to safety risk. The term reasonable practicability accepts that safety risk is not zero and that an assessment, typically a quantitative calculation, must be made comparing the total safety risk estimate to the cost involved in terms of money, time, effort, and reliability of implementing measures to avert or reduce the total safety risk. ALARP also has been associated with a disproportionality factor that increases as the estimated total safety risk increases. This could also be known as a precautionary principle. There's a non-one-to-one utilitarian analysis. In other words, the escalation of a LARP goes up as you are less certain of the outcome. LARP decisions therefore balance on professional judgment after analysis of total safety risk versus the life cycle cost of implementing any kind of risk reduction measure and the residual remaining total safety risk. A LARP also is frequently tied to the concept of a tolerable risk framework. You may have seen the tolerable risk framework in various forms, but it's generally signified by stoplight colors, red, yellow, green. It's sometimes shown as an inverted cone with three regions, red on top, signifying unacceptable risk, yellow in the middle, representing tolerable risk, and green on the bottom, representing broadly acceptable risk. And we note here that the term tolerable does not mean that we accept health and safety loss. Rather, it means that there are individual and societal benefits to gas storage activities that balance and or outweigh the non-zero safety risks. Okay, so to apply a LARP, it will depend a lot on what your current state of risk assessment models are. Ultimately, you would like to develop a quantitative way or a quantitative mimic to what you're doing so that you can actually do cost benefit analysis based on the reduction in risk. So a few bullet points here that you can see on the slide. Our suggestions are try to create ways to quantify the likelihood of loss of containment and the related safety consequence severity. Create the ability to aggregate total safety risk on a system component, such as an individual gas storage well, as it might affect an individual over the annual operating or other current life cycle phase. And then you'd like to annualize the likelihood of a loss of containment event, and the sum of the safety consequences of that event. And then if you can quantify this estimate of life cycle cost of the loss, and then quantify the life cycle cost of implementing some P&M measure to reduce the safety risk, you can start doing cost benefit analysis. It's also important that you recognize that any particular P&M measure may not be 100% effective. For instance, if you insert a downhole safety valve, you have to adjust the reduction in risk by the reliability of that valve. So let's say you estimate it's 95%. 5% of time it might not be working. And that actually factors into the analysis. So the more detailed you can be, the more appropriate will your ALARP estimates be. And at the end of the day, you're going to compare the estimated costs of implementing your solution to the net safety reduction benefit. Again, there's a lot to talk about. It can be complex, but actually very appropriate to apply in the storage risk management context. And with that, Shreyas, we'll turn it back over to you for a closure, and then we'll go to the Q&A. Thank you.
Yeah, thank you, Steve and Phil. Probably now let's open the floor for questions. If you have any question, please unmute and ask the questions, please. While we wait, we are going to share the presentation and also the recording of this webinar with you all.
I have a question for either Phil and Stephen. From a regulatory perspective, from a state regulatory agency, how would you guys advise state regulators to maybe implement the second editions, whereas the facilities already have implemented the first edition? Yeah, any thoughts on that would be great. Thank you.
I'll take the lead on that, Phil, and then you can chime in. of course, PHMSA will be auditing according to the second edition. They are now looking ahead. Again, their enforcement potential is live effective January 1 of the new year. From a state perspective, where the state is either auditing or partnering with PHMSA, I guess I would just say you would do the same thing, focusing on the shall statements, of course. The requirement to do things, has been known for some time. I have to say, I mean, the industry participated in the update of 1170 and 1171, and those were published in November 2022. So we are already 3.5 years live with those standards, and many operators are certainly familiar with what's in them. And so I would expect that many operators have been trying to apply, and adjust to the new additions. As we noted, though, 1171 has 20 or 30 additional shall statements. That's a good place to start. 1170 for cavern operators, of course, has a whole bunch of new shall statements, although many of those are embedded in the risk management section, which cavern operators were supposed to apply with the PHMSA final rule back in 2021 anyway. So there's that. So for reservoir storage in either aquifers or depleted oil and gas reservoirs, the focus on what are operators doing for reservoir integrity is kind of the newer area. Well integrity should be pretty well managed at this point, but like gas inventory analysis, pressure volume monitoring, looking at the boundaries of storage fields and making sure that the gas boundary is secure. Those are some of the new shell statements that I would think that an auditor would focus on, because those are the ones where maturity building is still happening. So I think from my experience in industry and partnering with the regulatory community, we want to see that as a symbiotic relationship where good auditing leads to better operations, and we're not adversarial. We're actually helping each other to get better from an integrity management standpoint. And so focusing on, well, what are you doing with these new shall statements, and where are your own weak points that you recognize, and where do you need to do better? I think those are good places to start. And that may not have answered your question, but maybe it gives you some ideas, and I'll see if Phil's got anything more to add. And then, you can do a follow-up if you'd like with the question.
I think you hit the nail on the head. Really focus on the shall statements, and then there are some of the like Steve gave an example with the interactive threats, where there may be a little bit of gray area between should and shall. At the end of the day, you probably need to default more to the shall side. I think with regard to cavern operators, the risk assessment and modeling effort is maybe new to some operators. That will certainly require some focus, and as well as the interactive threats on there.
Thank you both for sharing those. Yeah, we are focusing on the shell statements for sure. In Colorado, we only have the reservoir, like the depleted reservoir storage. So 1171 is the more pertinent one for us. The follow-up I have is so I noticed that the operators submit some sort of I forgot the name of the EIA form to report their annual inventory or maybe even monthly inventory. I was just wondering, this new second edition, the inventory monitoring and the pressure flow monitoring, how are they different from maybe what they do currently? I don't know if that's a too involved of a question, but just wondering.
Yeah, thank you for that question. I would characterize it. I missed all my gas storage friends on this call, but I would characterize that the EIA monthly inventory reporting. that's reporting. That's not analysis. So, if we're doing good storage integrity management, that relies on fundamental engineering and geologic analysis using data, but then good scientists and engineers do analysis with that data. So a gas inventory analysis is not simply reporting of volumes, it's actually analyzing the pressure volume relationship historically, trending it, looking at volume of gas per pound of pressure, looking at observation well data, looking at gas and fluid changes in the reservoir, mapping the pressures out throughout the reservoir. A whole lot of detail that actually good practices. They're not spelled out necessarily in 1171, but the industry has been doing a lot of gas inventory analysis for years. There are seminal works such as Dr. Donald Katz's Underground Storage of Fluids and other works that can dive in more to what makes a relatively robust gas inventory assessment. It's a bit hard for an auditor because if you're looking at the letter of the standard, it says do gas inventory assessment. But one of the key points I work with on clients is to say, part of doing that, you are supposed to evaluate the sources of uncertainty. Remember, all of 1171 is a risk-informed standard. It puts the onus on storage operators to assess the risk related to all aspects, reservoirs, wells, third parties, etc. So when a gas inventory pressure volume assessment is done, there are many sources of uncertainty, and we could tick them off right here, and then some. But just trying to come up with a good average pressure and fluid composition of a vast reservoir underground at depth, with the easy things are like meter volume inaccuracy, pressure measurement instrument inaccuracy, but then you go to the geologic realm in terms of, well, do you really know exactly where the edge of the gas is? And so these are things that gas inventory analysis goes way beyond simple reporting of numbers. I hope that helps.
Yes, that's great. Thank you so much.
Thank you for asking that question. Do you have any further questions? Please unmute and ask.
Yeah, I'd like to ask a question.
Go ahead.
Kind of continue on the should-shall discussion. I'd like to get your opinion on the incorporation and compliance with the should statements and how PHMSA would look at the should statements.
Again, I'll take a first stab, and Phil, correct me if I'm wrong or add to it. So the basic guidance that PHMSA has always given is that while the shall statements are understood to be mandatory, the should statements ought to be done unless you have a good reason not to do them. However, there are, just like we kind of talked about the 8.3.2 and 8.4.2 clauses, PHMSA talks about a nested should, or in other words, a statement that is a should that one could read from an English language usage standpoint that is nested under a shall statement, essentially makes it a higher level of mandatory than any other should statement that is maybe just out there in the 1171 or 1170 standing on its own. And that's a bit of a nuance. I know it's not clear, but the best of all worlds is usually to err on the side of caution. PHMSA will, when auditing historically, they have points of emphasis, and that's based on their lessons learned as they audit. And so just because they seem to emphasize a certain thing when they come along and have an audit of your facilities doesn't mean that they're not also interested in other things. It's just the amount of time available to do the audit. So to try to answer your question as best I can, I would say, be careful in reading the language, that if a should statement follows logically from a shall statement, that would be a higher order of magnitude in terms of your efforts as an operator to comply with doing that. And then say a should statement that would clearly be not connected with a shall statement. And there's lots of examples. We don't have time to dig them out, but we could do that. I think in the risk management section, so section 8 of both standards, you get a number of those where you have shoulds nested under shalls, and it goes to the robustness of your analysis, for example. And that would be similar to what we just talked about with gas inventory analysis, where the first edition had it as a should. Some operators didn't bother doing it at all because everything that followed was a should. So as a section 9.5 on its own, it was shoulds nested with shoulds. Well, now when you've made that in second edition a shall statement and then some shoulds follow, it's arguable what is considered a nested should underneath of that global shall. So I don't know if that makes it clear or muddies the waters, but I hope I helped you in terms of prioritizing the work on a should. And in general, I would say any should statement, you as an operator should go through and rationalize, does this apply to my facilities? Can I apply it? Why am I not applying it? What is the engineering basis for why I would not apply it? You know, so again, when something just doesn't exist in your facilities, great. But if it does apply, then there's something you ought to be doing about it. And the should statement gives you some considerable leeway in how you would do that. But if you look at it from a performance based risk management perspective, what you're trying to accomplish with that, with performing to that should statement is, did I hit the spirit of that should statement in what I'm doing? And if you are satisfied internally that your argument is that, yes, I'm doing that by doing this, I'm accomplishing the essence or the spirit of that should statement, then hopefully you've documented that. And when you get audited, and if you're asked about it, that's your documentation and your argument for why you've done it the way you've done it. I'll stop there. I don't know if that's really helped you, but I think it's an explanation that people do need to hear, that should statements are not to be ignored. They need to be treated, every one of them, and purposefully, and the significance of them, of course, you can judge, based on how they fit into your own particular facilities.
Yeah, thank you for that. It seems to pretty much align with our perspective as well. So just wanted to get your thoughts. Thank you.
Thank you. Any more questions?
Shreyas, I'd like to just add.
Sure, Steve, go ahead.
As we said, we only picked a few what we called FAQs, hit some of the high points. You may have others. And if you think about some later, I'm sure Shreyas will tell you how you can forward those into us. Again, I know many storage operators are using some sort of more qualitative or risk index model. And so when we think about, well, how do we actually measure performance with that? How do we do a LARP? Again, we've got a good number of ideas to help you, and probably every storage operator will have their own unique company culture, their own unique set of circumstances. We're very, very willing to help you out and work with you to give you some ideas on how you could advance things like performance measures and metrics and application of a LARP. But it would just depend on knowing exactly how what kind of risk model you have today and how you're using it. But we would like to work with you to get you there if you need that help.
As we wrap up today's webinar, I would like to extend my sincere thanks to Steve and Phil for sharing their expertise and helping us better understand the implications of the second edition API RP 1170-1171. If you need any assistance in implementing the second edition, please reach out to sales@rcp.com. I'm sure Phil and Steve and TaskOp team would be happy to assist. On behalf of RCP, Pipeline Safety Institute, and TaskOp, thank you again for joining us. We hope you found today's discussion valuable and look forward to have you join us for future webinars and training opportunities. Thank you. Have a wonderful day.
This video is brought to you by RCP and the Pipeline Safety Institute.